Good evening, everybody. Welcome to a warm summer evening. Well, summer. It's almost starting to feel like summer. We're getting pretty close to 100 degrees every day here, or almost 40 degrees C for you Euros. Now, let me get this muted before I start. Where is... Go. So, yeah, for you European folks on the centigrade scale, almost 40 degrees C it's getting to these days. So spring has sprung and we're starting to tip into some warm temperatures for summer. But a gorgeous calm evening, clear and beautiful tonight. So let's do some astronomy. Okay, so the first thing I want to do here is turn that off and start the way I normally do, which is to show you what my setup is. I am using a 6-inch imaging Newtonian telescope, a reflector telescope, on a Celestron AltAz mount that is mounted on a Celestron Wedge that is on my cinder block pier out in my backyard. And the pier and the wedge stay outside permanently polar aligned, and so they just stay outside all the time. I cover them up with a trash bag or something, and then the only thing that has to go in at night is the scope and the mount itself. Those are the things that are the more temperature sensitive things that you don't want sitting outside in the weather anyway. So yeah, so that's what I'm using for my equipment, and tonight we're going to be using the color camera. So we've got some color stuff we're going to see tonight. We're going to see actually some targets that we've seen already in the last month, in the last few sessions when we did some galaxy hunting. Tonight we'll see a few of those again, but this will be with the color camera, so get to see a little contrast, and we'll see some new targets tonight as well. But in the meantime, let's go take a look at what we are. Oh, and my computer wants food. Go. Okay. And so let's go back to my browser here. And so here are 14 objects. This is the Cloudy Nights April observing challenge, which we didn't get to work on last month because we were so busy with our galaxies. So tonight we're going to go through this list, or most of it anyway. And our first one is NGC 2419. So we will pull that up in our planetarium here. Come on, there you go. NGC 2419. Doink. Okay. So let's make sure we're good. We're nice and high in the sky. And we're going around a ways. Okay. Well, we will go around to it. This will be a nice big cluster. Intergalactic Wanderer. Okay. I forgot to put my little sequence in here to max target 533. Stretch stuff out. Oh yeah, there it is right there. It's pretty much centered up. It's close enough for government work. So let's start imaging on that. Hey Frank, good to see you. Thanks for stopping in. How are things over there on the East Coast? Starting to get warm here. I think I'm doing 60 seconds, but I have a feeling 60 seconds is going to be a bit much for this target. Globular clusters tend to be pretty bright, so we'll see what this does. Yeah, in fact, I'm going to drop that down to 15 seconds. Yeah, we don't need to do anything there because we didn't get any data yet. Okay, let's get our histogram adjusted here so it makes a little more sense. And see what we got. Yeah, see, there's our globular cluster right there. So let's zoom in on it a little bit more. Obviously, we're going to have to take some... I'm also getting some double diffraction spikes on these stars, which means even though I focused... Hi, Pimal, how are you? Frank, it still hasn't warmed up out there, huh? Okay, so I think these double diffractions, but yeah, I did do a focus a little bit ago, but it looks to me, yeah, that's the problem with having the scope flopped over like this when I'm wheeling around to different parts in the sky. Sometimes the focuser can allow the camera to move just enough to throw things out of focus. So this is looking to me like this is pretty out of focus. So I'm going to stop this, and we're going to sorry, 533. We are going to go to a nearby bright star. Castor will work beautifully. And no, I want to get Castor, not whatever that thing was. Sometimes in the Planetarium you've got to get in really close to actually select the target that you want. Okay, let's go over to Castor, and I'm going to mute this and put the mask on, and we're going to refocus for this star because it seems to be a bit out. So I'll be right back. Okay, it wasn't out by too much, but definitely enough. Okay, so let's go back to and to answer your question, Pamal, yeah, we're going for Caldwell 25 or the Intergalactic Wanderer. Okay. There you are. Start the imaging. Except I'm going to reduce. I'm going to reduce the... Clear that old one out. I'm going to reduce the exposure to 15 seconds because you just don't need something that bright for that long an exposure for such a bright object like a globular cluster. So, yeah, these diffraction spikes look a lot better. So hopefully we'll get some better resolution on the individual stars in this. I'll have to give it a few sub-exposures. And as more and more sub-exposures come in, we should be able to see more. Hopefully it'll resolve better, it'll clean up better. Oh, and what'll also help is making sure I get my enhancements put in here. which help with the sharpness quite a bit too. There we go. Now we're starting to see some individual stars out of that. So this is what's known as a globular cluster, which is a large, bright, dense cluster of stars, as opposed to an open cluster, which is a much more loose accumulation. And one of the current theories about what globular clusters are, there used to be a belief that they were the result of stellar nurseries that had birthed a whole bunch of stars, and those stars still hadn't dissipated out into space and separated from themselves yet. But more recent theories indicate that globular clusters are perhaps other galaxies, smaller galaxies, that have come into and perhaps even collided with the Milky Way galaxy, and through the gravity of the Milky Way have lost most of their outer stars, and just their dense cores are what's left. And in fact, this globular cluster here is out of the plane of our galaxy, as I believe most globular clusters are. They are out of the plane of the galaxy. And in fact, I think Gary here, yeah, so there is the Milky Way, and this is well above and outside the plane of the Milky Way galaxy. And this is true for most of the globular clusters. They seem to be outside of the plane of our galaxy, where most of the stars and things are. So, giving further evidence that perhaps they are satellite galaxies, dwarf galaxies, or something that that have come into the sphere of the Milky Way and kind of orbit around it and hang out with it, but weren't perhaps part of the Milky Way in the beginning. And so that's another reason why it's called the Intergalactic Wanderer, because it's probably come in from who knows where and just gotten into orbit with the Milky Way, much like a moon orbits a planet, comes into the gravity well of a planet and becomes a moon that orbits it. Entire galaxies can do this too. Small galaxies will orbit bigger galaxies and become satellites of them. And that's one of the theories about what's going on here with Caldwell 25. It's called the Intergalactic Wanderer. And let's see, do a bit of a color balance on this. Here, it's a little bit out. That's probably a bit too much blue. Wow. That's a lot of blue. Holy moly, why is that thing doing that much blue? That's a lot. That's probably closer to about right. Still a lot there, but it's alright. Closer to realistic colors, at least. My cooler is really cranking tonight down here. You can see there's a cooler on the camera that keeps the sensor at a target range of -10 centigrade. And the temperatures are just starting to get warm enough now that it's struggling to get it down there. Usually this thing is running, 60%, 70% to keep it at this temperature, but now the overnight temperatures, these nighttime temperatures, are starting to get pretty warm. So hey Doug, hi John, glad you could join, guys. Nice to see everybody. Clusters. So Milky Way and clusters. Well, okay, yeah. That actually does sound pretty good. So now that you brought it up, Doug, you have to bring enough for the whole class. So we'll be here for a while. We'll wait. You got to go bring some Milky Ways now. That was my favorite candy bar for a long time when I was a kid, Milky Ways. I love those. You bet, Doug. My pleasure. How's the clouds out there right now? You all socked in? Seriously. Yep. Well, so far so good here. Might be a little breeze here or there, but so far doing pretty good. So here's our intergalactic wanderer. Probably quite a few thousand stars in this bunch, maybe more. I'm not sure how big it is. So why don't we just look this up? It's NGC 2419. Yeah, 2419. So let me go and see if they have a Wikipedia. NGC 2419. Discovered by William Herschel. It's at a distance of about 300,000 light years from our solar system. The Milky Way is about 100,000 or so, 100 to 120,000 light years across. So this globular cluster is about 300,000, about 3 times that distance away. So definitely outside of our galaxy. It got the nickname Intergalactic Wanderer because it was thought not to be in orbit around the Milky Way, and it was just kind of traveling through. Its orbit takes it further away from the galactic center than the Magellanic Clouds, but it can, with qualifications, be considered as part of the Milky Way. At this great distance, it takes 3 billion years to make one trip around the Milky Way. So it wanders around us, but it goes real slow. It is one of the brightest and most massive globular clusters of our galaxy, so it is really big. It's 900,000 times more massive than our Sun. Well, does that mean? Yeah, so it's got a lot of stars in it, probably even hundreds of thousands. My estimate was low. It's a big one. Oh, I didn't put my background music on either. Let's do that. There we go. Yeah. So now you don't have to just listen to me yammer. Running the wooden wedge on the glued together concrete blocks. Geez, Doug, you make me sound like some sort of rickety fly-by-night operation. No, Frank is right. I've gone totally pro. See, I actually have the real Celestron HD Pro wedge now on my spare no-expense cement block pier. But yes, I actually have the real wedge now. And actually, I showed you that during our last live stream, the Cloudy Nights group live stream the other day. Yeah, I have gone full on. Well, actually what happened was I got a really good deal on it on Cloudy Nights used classifieds, so I picked one up. You're welcome for the music, Pamal. Yeah, it's better for the lulls. you know, and for some people it just lulls them to sleep, so, you know, that's good too. I am a cure for insomnia on these things, so MultiPurpose Events. Cool, well there's our Intergalactic Wanderer. Many, many stars there. It's one of the biggest globular clusters that we have in the vicinity of the Milky Way. It's quite a patch of stars out there, so it's 3 times the diameter of the Milky Way away from us, so it's a pretty big deal. So, cool. Alright, so there's that. Next target 533. And let's see what we got next. So what we got next is NGC 3242. So this is a planetary nebula. 3242. NGC 3242. Doink. Alright. We're almost 30 degrees up, so that should work. Lift to the south. We'll zip around. Yeah, Frank, that's the HD wedge. That's not the regular Celestron wedge for the, you know, the normal evolution wedge. This one is actually the this one is actually the HD wedge that's designed for the CPC. It's the heaviest duty wedge. So I intentionally always overbuild, and no exception here. Okay, there it is, right there, nice and bright. Very bright little deal. Let's bring it more into the frame here. Doing, doing, doing. Bring it right into the center. Woo! I think I went a little far on that one. Not too bad. Bring you back a little. That'll be close enough. Alright, Planetary Nebula. So here we're going to actually be able to go for the full deal. And go for the full 60 seconds on this. But this is going to be... in fact, let's get this. Let's get our view in there. Let's get this resynchronized since I just centered it up. And we do have a little bit. So this is kind of it's probably a Hubble image. So it's a little blue amoeba looking thing. But a planetary nebula is basically it's the death process of a star not unlike our own sun. It's a star that's too small to go nova or supernova, and it just starts, it burns up all of its, I believe it's hydrogen. It burns off all the hydrogen and starts burning helium, which burns a lot hotter, and so it actually burns off, blows out its outer layers into the surrounding space. But as it does so, it the core star of the star itself doesn't go out, doesn't stop burning. It becomes a brown dwarf or a white dwarf or something, a smaller, dimmer star, but it keeps burning. And so as the gases that it blew off, its outer layers, as they expand outward from the star itself, the core of the star itself, the continuing glowing star lights them up. And so we're seeing the expanding gases coming from the star that are being irradiated by the dwarf of the core of the star that was left, and it just continues growing. And so we see the different colors. Typically a bluish green means a lot of oxygen. Red typically means hydrogen. So this is not a star, but an actual planetary nebula. And as we get more sub-exposures in, hopefully I will be able to. It may just be so bright that hard to see, but we'll be able to see hopefully more detail as more sub-exposures come in. But definitely got the pretty blue color. So Galactic Wanderer should be my hiking handle. Yeah, you know, I guess that sort of would. When it's not Sherpa, I guess Galactic Wanderer would be an adequate substitute. Yeah, the Evo 8 mount does fit on the HD wedge. It can take both sizes, both the large CPC mount as well as the smaller Evolution wedge. And though I have never tested it, I would assume that because the Evolution and the SE mount can be on the same wedge, the smaller wedge, I would assume the SE can also go on this too. They must have the same bolt pattern. So I'm assuming all three of them can fit on this. This is just a bigger, heavier duty version, and so that's the way I like to do it. Overkill. Make it stronger than necessary, so hopefully that'll make the images more stable. This is very bright. Much brighter than I thought. Mag 8. The surface brightness is actually brighter than the overall magnitude. Well, we'll do this for, we've got about 4 minutes on it now. I might actually back this off, and we'll try doing it at 30 seconds and maybe even at 15, because it looks like at 60 this is just way too overblown. So that's what I'm going to do. I'm going to back this down to 30 seconds, clear the stack, and let's see what it looks like with a 30-second exposure. Maybe we'll be able to see more of the interior a little bit. Thanks, Doug. Appreciate you stopping by even for a few minutes. And good luck on the physical. Hope all turns out well. Well, we get a little more blue and a little less core, but I'm thinking it's still too bright. Yep, I'm thinking that's still too bright. So let's try it at 15 seconds. The good thing about going backwards with the time is it takes less and less time to get that first sub-exposure in. Good night, Doug. Yeah, that's a little bit better. Definitely have more blue and a little bit more interior. Let's do a few sub-exposures on this. We'll see what that does. I'm using, of course, the wrong dark frame on this, but as the dark frame is designed for the 60-second exposure, but I think we'll still get good enough to see what we need to see. Do a couple of minutes of that and see what we get. Let's try 7.5, just for kicks. Boink. Ooh, see, that gets too bright again. If we back off. Yeah, we actually start seeing a bit more detail. Let's let this run for a couple of minutes. See how much we can see out of it. It's a very small little thing, that's for sure. Most of them are not very big. There are some exceptions. The Dumbbell Nebula is one of them. That's a nice big bright one, multicolored. It has reds and bluish greens in it. You can actually see the pixels in the camera a bit because we're zoomed in so far. Zoom all the way out and see it in its full context, it almost looks like a star. It's clearly bigger than a star and a lot more colorful. And that's why I believe originally they were called planetary nebulas, because the early astronomers who first observed them knew they weren't stars. They knew they were bigger and obviously much more colorful, but so they assumed they were other planets. But then over time they realized that they never moved. Unlike normal planets, where the name planet actually means wanderer, planets travel through the sky, and it may take, like as in the case with Jupiter and Saturn, the outer planets, it may take them many months to march across the sky, but they do move. And these guys never seem to move, so they figured something was going on, but they weren't sure what. But the name stuck. There we go. Planetary Nebula, little guy. But let's move on to the next thing. What do we got now? Ah, the Leo Triplet. Okay. Yeah, we'll just do the fast way. Right underneath Leo. So we're going to try and get all three of these in here. And so what I normally do is I target this star, and we try and get that star. And if we center that, normally we can get them all in one. Well, I mean, I know I can get them all in one. Yeah, see, there's the three of them right there. And that came out pretty close. We just need to pop up a little bit to move the three of them up into the frame a little better, even a titch more, and then we'll get it up a little higher. The one at the top is called the Hamburger Galaxy, and that one's a fun one. That's one of the prettiest ones. One of the prettiest galaxies. Alright, one more pop. There we go. Okay. So, now let's go ahead and start on that. And these guys will definitely need the full 60 seconds. Oh hey Mark, that one was Caldwell 25, the Intergalactic Wanderer. Or NGC 4219, if you like the NGC catalog better, which is one of the largest and brightest globs, globular clusters that is orbiting the Milky Way, or I guess considered part of the Milky Way as it's one of its satellites, like those globular clusters tend to be. And good to hear from you, Mark. This is called the Leo Trio, and that's because these guys are right below the constellation of Leo, and we have done these in last month. We did these in one of our sessions where we did all the galaxies between Ursa Major and Leo and Virgo, and so this is one of the most popular galaxy. Trios, I guess, of galaxies that you can view, and they're all pretty nice galaxies. As always, galaxies are better with the mono camera in terms of contrast and sharpness and detail, but color offers some pretty fun stuff too. You can see we've been photobombed by a satellite here, so and here's 65 and 66 galaxies here. Both interesting looking. With the color camera, we might actually even be able to see the different colors of what's going on here. The more yellow cores. The cores tend to be more yellow, and then as you get outside, there tends to be more reds and blues. Like you can see, these pockets here are slightly blue. And those are high energy areas, typically areas of dense star formation, where there's just a whole lot of young hot stars that are being formed. There can also be red areas as well, where there's some similar stuff going on, but you can see there's sort of bluish pockets out around here. And if you take long enough exposure, you can see some of the red pockets. If you look at Hubble images or astrophotography images of galaxies where they've taken hours and hours and hours of data, just open the shutter on the camera and just let it soak in all those photons, then you can see more red packets. But I think I don't usually see much of that with a 60-second exposure like what I'm doing with these. Let's make sure, yeah, this would also help if I was actually properly adjusted with the histogram. That might be a little much. We'll see what that does. There, that'll look a whole lot better. I was way out with the histogram. But yeah, these are definitely areas of bluish as opposed to the very yellow core. And this one has a lot more. I think this one is 65. No, that is 66. So 66 looks like it has definitely some bluish areas of star formation, pockets of high energy star formation, and 66 over here, or 65, is more of a more mellow. A few little things here and there, but mostly just a spiral. And then, of course, up here is the coolest looking one, and that is what's called the Hamburger Galaxy, with its very prominent dark dust lane, and we're looking at it almost perfectly edge-on. So you can see a lot of stark detail in the dark dust lane on the outer edge here, and then all the glow from the sides of it. I mean, it looks totally three-dimensional. It's a very cool galaxy. And I believe these are all about 50 or 60 million light years away. This one's 45. I think they're all right about the same. This one's about 40. Unknown. But they're all about in the same same distance. But this is about 45 million. 45 million light years away. So we are literally looking at 45 million year old light. We're looking at the galaxy as it looked 45 million years ago. It's about 44 million light years before man was even walking on the planet. So we have no idea what it looks like today. We'll have to wait 45 million years to find out, but it's kind of cool. Down to our friends down here. Another satellite photobombing through. These are starting to come in nicely. You can see a little wispiness around the outer edge. Give that a little more boost. And also, I should color balance it too. Come here, you. Color balance. Doink. Yeah, that's pretty nice. But they're all very pretty galaxies, and if you got a big enough sensor on your camera, which mine is just barely, you can get all three in the image. So, all three of them hang out right there underneath Leo. Pretty cool. Up on our 10th minute. There's 10 minutes on the Leo trio. A fun one to be sure. But moving on, more to see. Next target. Okay, and what is the next target? Okay, 2261, the variable. Catch it early or you'll miss it. Uh-oh. Well, let's see if it's still up. 2261. NGC 2261. Doink. Ugh. 20 degrees. Yeah, I'm not even going to bother with that one. That one's already gone. It's a very small one anyway. But yeah, 20 degrees is going to be too low for me. It's going to be in a building. So we will just skip to 104. And 104. Alright. The Sombrero, another nice edge-on galaxy. Center just a little bit more. That'd be about perfect. Yeah, okay. And we will start on this one. This is about, so this galaxy is about 30 million light years away. And just about to come in with our first sub. Nice little chain of stars there. There's a bright, spectacular one. Look at that. That's pretty cool. Let's darken it up a little there. And back off just a little bit here until we get some more data in. But another one that's almost perfectly edge-on, but a very sharp dust lane around the outer edge. Oh, cool. Good to hear that, Pimal. Yeah, it's the Sombrero is definitely one of the nice ones. this a little bit more. Definitely a really bright core on it. It's no wonder Charles found it. It's a real bright one. And for the sake of your class, M104, right there below Virgo. Virgo, Corvus, and Crater right in there. So finding it with the scope, it kind of nestled right in between all those constellations. Leo is up there, Virgo, Libra, the zodiacal constellations, and this is just off that by a little bit. You're welcome, Percy. My pleasure. I started doing this last fall, I think. Just enjoyed doing this stuff and found a way to share it. So I'm enjoying doing that too. I guess a silver lining in this pandemic cloud of online stuff. It inspired me to do this, and I'll just keep on doing them. As long as people want to watch anyway. There's always somebody geeky enough to like this stuff, so somebody will always be watching. Oh, don't worry, I'm not going to give up. I like doing this. Been doing it my whole life, pretty much, since my parents bought me my first rickety little Sears. I don't know if it was from Sears, but my first refractor telescope. Rickety little wooden legs on it, but I loved it. And it got me out there, and it got me hooked. So it was good enough for me to see stuff. Probably then it was mostly solar system stuff, the moon and planets and those kinds of things, but eventually expanded into other stuff, and later on in life bought my first Dobsonian telescope and then could see faint fuzzies, and got into the deep space objects, which were always more interesting to me, but required bigger gear to see them. But even with the biggest Dobsonian telescopes, I still was never able to see things the way I wanted to. Faint gray fuzzies were still faint gray fuzzies. Until about 3 years ago, when the concept of putting a digital camera into your eyepiece instead of into your focuser, instead of an eyepiece, that just totally, and then the images I could see, wow, it just totally blew me away. And with the advancements that they're making with digital cameras anymore, both for the security camera industry as well as obviously smartphones, cell phones, the sensors just keep getting better and better and better. And while most sensors are not designed for low light work, they're still continuing to get better and better and better, and the astro cameras get better and cheaper as we go along. So it's been a lot of fun. Continues to be fun, and I continue to finally be able to see things the way I wanted to see them, in color and nice and bright and in their full context. All the stars around them. That's still a pretty little chain of stars there. But you can see how bright this galaxy is. It's really bright. Not very many. It says Mag 8, surface brightness of 12, but boy, it looks a lot brighter than that to me. Looks a lot brighter than that to me. At least tonight it does, but it's a beautiful core. Nice round core on it, and a nice sharp dark dust lane going around. Pretty galaxy. But we've been 10 minutes and it's time to get to the next thing, which is going to be what? 96. Okay, that's also right in this area, I believe. M96. Yeah, it's one of the ones, also another one under Leo. So it's not... So the Leo trio is right here. That's the one we just did just now. This is another group of galaxies. And I'm pretty sure if I pick this star, I can get 95 and 96 in one go. So that's what we're going to shoot for. Because I've done this already. We did this a few weeks ago. When we were doing our galaxy hunting for galaxy season. And alright, there's one. Oh, why am I not seeing the other one? Then the question is, you know what? I'm seeing just a faint puff of light here. I'm going to take a guess and say it's over there. Let's see. Yes. He guessed correctly. Let's see, get those both in the image and go for it. Start imaging. And we'll get these two guys here. Alright, M95 and M96. Both nice little spirals. Not exactly face-on, but much more face-on than the edge-on galaxy we were just looking at. We actually get to see their whole shape when we look at these. So... what is the distance on these? 95, 96 is, again, about 30. And this one is about 32. Yeah, same thing. 30 or so. Yeah, but you can start to see their shapes already showing up. The nice circulars of barred spiral galaxy. both barred. You can see there's a thick bar part, and the outer circle, and then a really outer circle. Kind of three different zones of star structure in them. Make sure I get the histogram set properly here so you can see stuff. Yeah, try that. That'd be a little bit better. That should show up better for you. I can. There you go. Off to the side a little bit there. Don't need to have that there the whole time. So John, well, Mark wants to know the scope I'm using. Well, here, I'll just put it up on the screen. I'm assuming he can see it. It's a 6-inch f4 imaging Newtonian. Just a simple reflector telescope, but it's f4, so it's a little bit faster, so it collects light a little bit faster. And it works real well for doing the imaging. Nice wide field. About 600 millimeters of focal length, so it works really well with the cameras I have. And it's all just riding on a Celestron Evolution AltAz mount that's on a wedge and cinder block pier that stays out permanently. The wedge and the cinder block stay out permanently polar aligned. And just the mount and the scope and everything else goes in with me. The rest stays out here under a trash bag or whatever. And because it stays polar aligned, I don't have to worry about polar alignment every time I set up, which is a big time savings for me when I set up to do my observing. So hopefully that answers his questions well enough. It's a bummer that he can't chat from whatever device he's using. M96 and M97. The 96th and 97th objects of Charles Messier's list. List of things that were not comets. Charles Messier was a comet hunter, and he kept scanning the sky for comets, and he kept running into these bright objects that he kept running into over and over again that were not comets, and finally he decided to just make a list of stuff to avoid because they were not comets. And his list of what was, at the time of his death, 103 objects long, and has since expanded to 110 objects because researchers later discovered in his notes that he actually discovered 7 more objects but just didn't ever publish them, hadn't gotten around to updating his published list. But he created basically a list of the 100 or so most bright, beautiful, and spectacular objects in the sky that now almost every amateur astronomer looks at, uses as at least something to start with to do their observations, because they are the prettiest things to look at in the sky. And so it's one of the most popular lists that is used in astronomy, especially by amateur astronomers, because it is it's just some great stuff. And it was originally intended to be, ironically enough, a list of stuff to not look at. But no, I'm not projecting any of this stuff. I don't have a projector to do that. So I'm just doing this just strictly online, just on my computer screen, which is then live streamed into YouTube. So yeah, Mark is amazed. Yeah, it does. With the modern digital cameras that they have now, it does not take much of a scope to be able to see some really spectacular stuff. The cameras now, the digital CMOS cameras now have have such incredible sensitivity and dynamic range, and they just get better and better and better all the time. So it doesn't take, it doesn't take much scope to be able to see, with a 60-second exposure, and that's what I'm doing right now. You can see here when this software that I'm using is called SharpCap, and down here, this progress bar down here in the bottom right-hand corner, this is an exposure being taken. So this takes 60 seconds exposures. So every time a new exposure gets taken, the way this software works is it stacks the exposures. So it takes a 60-second exposure, plops it down on the screen, and you see it. It then takes the second 60-second exposure and aligns the two exposures using the background stars and adds the second one onto the first. And then it does the same with the third one, and the fourth one, and the fifth one. And with every sub-exposure that is put on the stack, the signal-to-noise ratio goes up. Bright parts get brighter, dark parts get darker, and your signal-to-noise ratio and your contrast goes up. So instead of taking one 10-minute long exposure that requires extremely accurate equipment to track and take that type of exposure, what you do now is you take 10 1-minute exposures or 20 30-second exposures, and you stack them using this stacking software, and you get almost the same image, but because you're using much shorter exposure lengths, you don't need to have big, expensive, extremely accurate tracking hardware, mount and scope and everything else, to be able to get the images, because you're only having to track fairly accurately for 30 to 60 seconds at a time. And so relatively inexpensive equipment like what I'm using can take some fabulous images, and you'll still get a lot of dynamic range and a lot of very high signal to noise ratio because of the stacking that's going on, which increases your SN ratio. So it's the development of the modern CMOS camera sensor, and the software that can do all of this magic has really changed the way video astronomy can be done in the last several years. And as the cameras continue to improve and the software continues to improve, it just gets better and better and better. And the gap between the dividing line between full-on astrophotography and what is called EAA, or electronically assisted astronomy, which is what I do, short exposures being stacked so that you can see them in more or less real time. The gap between them is closing very quickly, and the lines are beginning to blur as to what is astrophotography and what is EAA and what is video astronomy, and how are they different, and are they different. And so it's a pretty exciting time. And it does not take big expensive hardware to do it. When I put the whole thing together, all on the used market, I bought the scope for a couple of $100, the mount for about $550 or $600, the wedge for a couple of $100. I mean, it just on the used market, you can just piece this stuff together. So, for $1,000 or less, I've got this entire setup here that can do this stuff. The cameras are where the money is invested. My cameras were about $800 each on the used market, and that's where you invest the money, but that's where most of the technology is, and so you pay for that advanced technology. But it's come a long way in the last 4 or 5 years. It's come a long way, and I've only been doing this for, like I said, 2 or 3 years, and it's changed even substantially in the time that I've been doing this, which is virtual blink of an eye. So, but there's 10 minutes on M96 and 97. A couple of nice barred spirals, about 30 million light years away. So let's get to the next one. Alright, what do we got next? Okay. The owl. Okay, yeah, this is another really small one. And that's up in the northern sky, so we're going to have to flip completely around to see that one. But M97 that is up by Ursa Major. Yeah, so right at the Big Dipper. Right underneath the Big Dipper. So we're going to have to zip around to the other part of the sky. Oh, in fact, even more so than that. The scope goes almost upside down, so we may actually have a little bit, yeah, the focusing. So I'm actually going to have to refocus because the scope flips upside down on this one. Well, actually it kind of pulled in okay. And let's see if I can get away without focusing. Let's see what happens if I don't focus. Grinning from ear to ear, geek, huh? Well, yeah, modern technology can make up for some stuff, but that nice 16-inch scope of his is still a pretty nice thing to play around with behind the bistro. It was fun when we had lines of people out there and everybody coming up to see what we could see. That was a lot of fun then. Owl Nebula, another planetary nebula. Although unlike the little guy, the really little guy we saw last time, the Ghost of Jupiter planetary, this one actually was big and bright enough for Charles Messier to see it with his little scope. Well, probably not. Well, certainly not a little scope in that day, but definitely this one will be significantly bigger than what we were looking at before. So it may be slightly out of focus, but you know, you can see the double diffraction spikes here because the scope has flipped upside down. Just flops the focuser just enough to take it out of focus a little bit. But for a planetary nebula, I think we'll be okay. I don't think it's worth going through an adjustment just for this. We just got photobombed by a satellite, and my internet seems to be blipping up and down again. Yeah, my internet seems to be doing flip-flops. So you may lose me a little bit here and there. You may see a little bit of buffering here and there. Are on their way? Does that mean they're actually coming over here? But sorry if the internet is, if you're getting some buffering and not hearing me quite so much. It's, the internet is doing some weirdness again. I'm actually quite surprised how good my internet is out here, given where I live. But it does have its challenges. It does have its spiky moments. Let's crank this up even more. But again, another planetary nebula. Outer layers of a star blow off and blow outward away from the core of the star, which continues to glow much more dimly than it was before, but it continues to glow and ignite or make all those gases that just expanded out into space glow. And so they're pretty interesting. They're pretty interesting objects. Sometimes they're just circular. Sometimes they have interesting shapes, like the Dumbbell Nebula has an interesting apple core or dumbbell shape. So they can do some interesting things, but mostly they're symmetrical in their shape, one way or another. But the owl is a pretty nice little one. And because it's near the Big Dipper, it's in a pretty convenient place for most of us in the northern hemisphere. So it's a fairly well observed object. Photobombed by another satellite. You can see this one definitely is much bigger looking than a star. The last one was almost the same size as a larger, well, appearing as a larger star. The reality is stars are The reality is stars are just points of light. They're just point sources, no matter how you slice it. So, even though some stars look bigger, it's just because they're so bright they saturate the pixels on a camera. So, but they're all point sources. And, but really small planetary nebulas almost look like stars, almost look like a bigger, brighter star. But it's a pretty blue little fuzzball. Not much more to it than that, though. You can see this core, the central core star. It's the star that's most probably at the center of this, making it all glow. Or it could be a star that's between us and it, but it's probably the star in the center of it. But we're not going to get much more out of it than that, so let's go on to the next target. Abel 135. Abel 135. No, what am I doing? Bell 135. Let's see if I can find that. A Bell 135. Yep, we can. Okay. Wow. That is in the southern hemisphere. A Bell 135. Wait a minute, what the heck is that? 96. SH2-290. I don't even know what the ball. A Bell 135 is obviously not. SH2-290, did I say? Okay. Well, that's a little bit better. It's another planetary. Okay. In the western sky, still about 35 or so. Okay. Well, we can give that a shot. Alright. Yeah, it hasn't dropped into a roof line yet. So we should be able to see something here, I guess. Well, let's see what we can see here. Oh yeah, oh wow. That's kind of cool. Maybe that. Huh. I keep thinking I'm seeing something here, but then I'm not really sure. Yeah, that's right. Well, I would assume I'm close enough. Let's run our first sub exposure on it and see what it does. Oh, I see what. Yeah, I see why. This is a magnitude of 15.5 with a surface brightness of 21. So this is, in other words, it's the higher the number, the fainter it is. This is really, really faint. So we may or may not be able to see this. We will have to see. Well, we'll know in about 15 seconds. Seeing much anything there. It's a pretty picture. Probably the Hubble did that. Well, the other thing I can do yeah, that's not going to get me much. So let's confirm that I'm even on the target. So let's do a plate solve. And see if I can confirm that we're on the target. Yeah, John, when I'm in my planetarium, this image that we're seeing of this nebula is probably a Hubble image. But I'm not sure if we're going to be able to actually see it through my camera or not. Only 0 stars found. Okay. Let's do a plate solve with a 4-second sub-exposure. There we go. It's off by almost half a degree, 4/10 of a degree. But I'm still not real hopeful that we're going to see much here. Yeah, we'll try. We will try to do another 60-second exposure. But with those magnitudes so high, this is a very faint object. So even though we're seeing nice, pretty, colorful thing here, this thing is really, really faint. So not holding my breath that we're gonna see anything through through my camera. So we'll have to see. I don't think we're going to see much of... yeah, that's another 60-second exposure. I don't think we're going to see much of anything. So I think this is going to be pretty much a bust. So we are going to just move along. And it looks like Mark and Shelley did drive over here, so I've got some visitors. Alright, so let's go. Next object, NGC 2403. I'll try that one. NGC 2403. Yeah, okay, it's a nice little galaxy. We will move over there. So I got some guests here, so I've let's see if I can get onto this next object, and I will say hi to them. But so we got that in the frame there. Let's see if we can't just move it over here more into the center and get this galaxy stacking. Yeah. This right now, no, this actually is NGC 2403. This is not one of the Messier objects. Start imaging. So, yeah, so that's going to take a minute or so to build, and I'll be back. Okay, I am back. Just had a couple of friends stop by, so chatted with them for a couple of minutes while we let this build in. It's come out pretty nice, I think. Let's see how our histogram is. Yeah, it's not doing too bad. Got some nice structure to this galaxy. Let's do a color balance. We haven't done that in a while. Yeah, it's pretty good. It's pretty good. Interesting little galaxy. Coming up on 9 minutes of data on that. There's 10 minutes. Cool. Okay. Alright, and next it's going to be 4038 antenna galaxies. 4038. GC 4038. Yeah, okay. Southern sky again. So, back around. Didn't really plan these out geographically, but let's see. Couple of different things in here. Huh. Oh, I wouldn't know. That's too far out. So it looks like we're definitely got something down here and something up here. This definitely looks like the antenna galaxies up here, but there's something else down here too. You know what? I'm just going to leave it right here. I'm just going to leave it right here and let's see what we can see. See what we can see with just this right char. What are the distance for these? Oh, 90 million light years. So this one's a bit further out. This one's a bit further out. Yeah, we definitely have another little guy down here. And the reason I may not be seeing it in Stellarium is because it may have dropped below the mag threshold. So let me see. turn these off and see what else shows up. Yeah, see, there's a bunch of things in here, and this is probably the one that I'm seeing. Yeah, because we're kind of focused in here. So I think this is probably this other one here. PGC 37910 is this one down here. Yeah, it's a Mag 15 galaxy. Yeah, so that's probably what this is here. But the ones we wanted to focus on were up here. It's like these two intertwining tadpoles that have their gravities are interacting with each other and kind of pulling each other apart a little bit. Well, thanks, John. Thanks for showing up tonight and for communicating with Mark, who couldn't chat with me, and passing along the messages. So glad you guys enjoyed it. Always good to see you guys. Sleep well, my friend. Night, John. These aren't interesting looking, though. Look at this. Their cores are just... they've like pulled each other completely apart. It's kind of cool. A bit more histogram. Again, this would look better with the mono camera, but be able to pick up a little bit more of the faint details, since some of this really is just really faint. The tails on these are just really, really faint compared to the bright cores. So you can just barely make out their wispy little tails, like two tadpoles or something. Let's see what a few more minutes of sub-exposures we'll get. Pretty faint little guys. This one down here is actually kind of interesting. Another one that seems to be pulled a little bit out of shape, with the core being way off center. cores are starting to come out a little bit better, but I don't know that we're going to get a whole lot more out of those tails. Probably stretch it a bit harder now. That might make a little bit of a difference, but don't know that we're going to get a whole lot more out of that. Just very faint little wispy tails. Well, we'll go to 10 minutes to give it its full due, but there's 10 minutes. Neat objects. Be interesting to do those with the mono camera. But for now, moving on. Asteroid, I'm going to pass on the asteroid. Variable star, M95. Yeah, we'll do these last two and call it a night, I think. M95 certainly a good one to do. Not from this piece of software. There we go. M95. M95. Alright. Doink. Yeah. Oh, haha. Oh, duh. No, 65 and 66 of 1 million. 95 we didn't do. Okay, let's make sure we're in there. Yeah, there you go. You're right there. That looks good. Let's get you going. Start the imaging. And then while that's doing that, you can see I've got a screen littered with red circles that indicate galaxies because I have my filters turned off, and this is why I keep them turned on. There are billions and billions of galaxies out there. I mean, I don't even have all the catalogs loaded, and you can see all the galaxies that exist. So I have to turn my filters back on so that what I'm seeing makes sense. Yeah, so we've seen the Leo trio, we've seen M96, now we're seeing M95. Nice little galaxies in here. Yeah. There we go. Some time to come in. Another barred spiral. Kind of three zones of nice bright core, and then a fairly bright ring around that outside the bar, and then a very faint cloud surrounding that. So again, about 30 million light years away. Not too far away. Fairly close by galactic standards. It's starting to come in nice. Definitely getting a lot more definition now in this inner star ring. Bar is coming out a little more clean as we collect more subs. We'll see a little. Well, I can't tell if that's a pocket of star formation or a foreground star, because all the stars we see here are yeah, David, we're on M95 right now. I'll probably do this one and then one more, and then I'll call it a night. But yeah, we're definitely still here. But all the stars you see in these images are in our galaxy. They're very much in the foreground, somewhere in the arm of our Milky Way galaxy. And the galaxy is obviously 30 million light years away. So it's hard to tell sometimes. Now usually stars in our galaxy are pretty sharp. You know, they're sharp and well defined, usually pretty bright. But then you get something like this, which is just a little sort of little blob of light there. It's hard to tell if that's a foreground star or if it is a pocket of high energy star formation or something in the other galaxy. Another little pocket there. As we collect more sub-exposures and get a little more detail, kind of stuff pops out a little bit. But we're just about coming up on our 10th minute. I try to do about 10 minutes on things that the faint stuff. Beyond 10 minutes, things will continue to improve, but very small, very insignificant, so bang for the buck happens in the first 10 minutes usually. But there's M95. Oh, that is a foreground star? Okay. There you go, that makes sense. Alright, and now the last object we're going to look at. 3C273. Quasar, variable star, variable galaxy and quasar. 3C273. Let's see if I choose 73. Yeah. That does not exist. That does not exist in 3C. Yeah, it doesn't exist in any catalogs in Stellarium. So, 3C273. The antenna galaxies, yeah, I already did that. Rest, there's 95. It's a variable galaxy. And quasar, blah blah blah. That. Red yellow star, Tycho 2282. Well, I wonder if we gonna. I don't know that I'll be able to find this one. I'm not sure where it is. If I had an RA and DAC. Well, there is an RA and DAC there. Let's see if I can do that. F3 is in bad position. If I go RA and DAC. $187,2764. need the decimal. I don't have it in... Shoot. Well, there's the RA and DEC in decimal format, but I don't know how to put the decimal format into 187 point what did I say it was? 2764. 187.2764. It's that one. Huh, it automatically does it. Okay. And 2.0578. 2.0578. Huh. Really? Okay. Let's go there. I mean, I'm basically already there anyway. So, I'm not sure. Yeah, 1, 2, 3. Oh! Yeah, you know what? I've seen this already. I have seen this. So I imaged this before. Yeah. Wait a minute. What am I looking? Should be in Virgo. I'm over here. Okay, I see. I haven't actually changed my position. That's why. I did not actually send the scope to it, so that's why I was having Oh yeah, thanks David for putting those in. As it turns out, Stellarium automatically converted the decimal to the non-decimal format, so it all worked out. So now, it seems to me I have imaged this. This is looking familiar. This is looking familiar. Yes, that little triangle of stars, yeah. Where this star... I have seen this before. Well, let's see what we can see. See if I can see any of the galaxy at all. And if not, we'll just call it a night. Okay, so here is where we're talking about. This little triangle of stars right there, which is the same as this little thing right there, which is the same as this little thing right there. And that is it. Variable galaxy. Ranging in a quasar ranging in brightness from 12.2 to 13.6. The cycle for these variations has not been. It took this first image using a placeholder after my slew and assumed I'd see a faint fuzzy disk or a glow. There is not even a hint of galactic glow resorting. I was able to identify from the image again. Mark the location of the yellow indicators. Yeah. Yeah, so this is 10-second exposures. I'm using 60-second exposures. You can definitely see the stars that are in there, but I don't see any galaxy there. let's try going back into Stellarium and again releasing the filters to see if we can actually get a... see, even with the filters all there, I'm not seeing any galaxy. There's a galaxy down here, and there's one up here, but I don't see a galaxy in here. So, I don't think we're going to actually be able to see anything. Let's pull in this last minute of data and see if it comes up with anything, but I don't think we're going to actually see anything here. So I think this is probably going to be it for me for the night. Yeah, I'm just not seeing anything in there. Looks like just a pocket of stars to me. So, yeah, I think I'm going to call it a night. Thanks everybody for joining, and stay tuned. I'll be this week is looking like the weather is going to be decent. I probably will not do anything tomorrow night. I don't like doing things 2 nights in a row. Too much live stream fatigue on me and you. So, but stay tuned. I'm sure I'll be doing something else later on in the week, next couple of nights, 2 or 3 nights. So. Stay tuned. But in the meantime, thanks for being here, everybody, and I'll see you next time.